Hello and welcome. Today I have a handout over chapter 2.4 and 2.5, which I will share on my screen. And we will begin with set operation and Venn diagrams using three sets. Operations that we will cover are the union, the intersection, and the complement of sets. So in this first problem, we will be using the set defined below and then perform the following operations. The universal set has the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. The set A has the number 1, 2, 3, 4, 5. The set B has the number 1, 2, 3, 6, 8. And the set C has the numbers 2, 3, 4, 6, 7. So when we draw the Venn diagram, although it's really not necessary for the problem, we can actually just look at the groups of numbers to do this. But if you're visual, I would draw this. The universal set is represented by the rectangle. Set A, B, and C are three sets, and by default, we draw them so that they are overlapping in case that we have elements that are in common to the inside regions. And we always start from the innermost region, which is the intersection of A, B, and C. The numbers that are common in all these three sets, including the universal, are the numbers 2 and 3. And you can see where I started crossing off numbers as I fill in my diagram. So 2 and 3 go in the middle, and then what's left that's in common with both A and B, other than 2 and 3, is the number 1. So we're going to put 1 in there, and then we're going to look at A and C. What's common to A and C, other than 2 and 3, is the number 4. And then what's common to B and C, other than 2 and 3, which is already in there, is the number 6. And now we could fill in the numbers that just belong to A, B, and C. So what we have left in A is the number 5, what's left in B is the number 8, and what's left in C is the number 7. And what's left in the universal set, once we've covered all of these numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, is the number 9, and that goes outside. So now we could perform the operation. What is the union of A and the intersection B intersects C? So we first begin with finding the intersection of B and C. And looking at our Venn diagram, or just the numbers here, we're looking for elements they have in common, which are the numbers 2, 3, and 6. When we find the union of A and the set B intersects C, we want all the numbers in B intersects C with all of A, which is 1 through 5. And so all the numbers represented here are 1 through 5 and the number 6. In problem number 2, we're looking for the intersection of the sets A union B and A union C. So the union is everything in A or B or both. So the union of A and B is 1, 2, 3, 4, 5, 6, 8. You could also see it here in the list. 1, 2, 3, 4, 5, 6, and 8. And the union of A and C is 1 through 5, 6, and 7. The intersection means the numbers that are common to both of these sets, which is 1 through 6. And now we are looking for, in number 3, the complement of the union of A, B, and C. So the union of A, B, and C is everything in all three sets, or both, or two combined, or by itself. So we need everything in all three sets. Going back to our diagram, that's all the numbers 1 through 8. but the complement means what's not in this set, so what's left is a 9. In problem number 2, we're going to use the Venn diagram below and then list the regions represented by the following sets. So set B is represented by the regions 2, 3, 5, and 6. Set A intersecting C. So we have these two circles, and the intersection of these sets is what's inside, which is 3 and 4. All right, moving on to problem 3. Use the Venn diagram below. List the elements in the following sets in roster form, which is making a list. And we call these braces. So a roster is a list of numbers inside braces with commas that are separating each element. Set C has the numbers 10, 11, 13, 15, and 17. The intersection of A and B, and I drew an intersection of these two sets, is what they have in common, which is 7 and 13. The intersection of all three sets is what's in the middle, and that's 13, set 13. In problem number 4, use the following Venn diagram to answer the questions. Which regions are represented by the intersection of A and the complement of B? So the complement of B, I try to do a sketch here, is everything outside B, and then that intersecting with A is what's highlighted here in this half moon shape. So we have A, and the intersection of A with the region outside B is what this half moon shape is, and that's region 1. In problem number 2, which regions are represented by the complement of A union B? So first we're going to find the complement of A union B. The complement of A is everything outside A, and then we find the union with B. So now everything that's shaded is represented by what's inside the parenthesis. The complement of what is shaded is what is not shaded, which is the half moon shape. Again, it's region 1. So these two problems both are represented by the same region, hence these two sets are equal. In problem number 5, the Venn diagram shows that there are a total of 6 elements in region 2. The cardinality of A is 37. The cardinality of B is 41, and the cardinality of the universal set is 77. So in order to find out how many elements are in each of these regions, we need to know what the cardinality of A is, which is 37, minus 6, and we have 31 left. And then set B, the cardinality is 41. When we subtract 6, we have 35 in this region. And in order to find out how many elements are in region 4, we subtract 77 minus the sum of 31, 6, and 35. So the sum is 72. So 77 minus 72 is what's left in region 4. So we have 5 elements in region 4. In problem number 6, use the following Venn diagram to answer the questions. How many elements belong to set A or C? That's the union of A and C. So everything in A, everything in C, or both. So that is 4, 5, 6, 7, 8, and 9. Add them all up, and we have 39 elements. How many elements belong to A and C? Well, that means what is the intersection of A and C? So or means union, and means intersection, or the elements they have in common. So the elements that are in A and C are 5 and 9. 5 plus 9 is 14. How many elements belong to set B and C but not A? So what's common to B and C is 9 elements, but not in A. So we want to rule out the 5, and we have 4 left that are in B and C, but not in A. And the next question is how many elements belong to set B or C, but not in A? Very similar to number 3, only we're changing the language to or, which means the union of B and C, but not in A. So we can visualize it. We don't want 7, 5, and 9 in there. So what's left in B and C are the numbers 3, 4, and 6. When we add them up, we have 13. So that covers handout 2.4. The next handout is a survey problem. This is an application of sets and Venn diagrams with 3 sets. So in this problem, a survey of 110 college students was taken to determine the types of music they liked. Of those, 36 said they listened to rock, 48 said they listened to classical, 32 said they liked jazz, and 13 said they liked both rock and jazz, 26 liked both rock and classical, 21 liked classical and jazz, and finally 11 said that they liked to listen to all 3. Construct a Venn diagram to find the cardinality of each region and then answer the questions. So we first have to draw a Venn diagram using 3 sets representing rock, classical, and jazz. And I've got my R, my C, and my J here. And then the universal set, they did a survey with 110 students. And then what I like to do is work backwards from the innermost region. And this region is what all 3 types of music, how many students liked all these 3 types of music. And so starting with the number 11 that listened to all 3, we put that in the middle and then work our way backwards. 21 liked classical and jazz. So we have 21 that liked classical and jazz. And so 21 minus 11 is 10. So we have 10 left here. And then it says that 26 liked rock and classical. And so we already have 11 here. So 26 minus 11 is 15. And then we have 13 students that liked rock and jazz. So 13 minus 11 is 2. And now we've already filled in all the intersections. What's left are the number of people that liked rock alone. Or if you want, we'll continue to go backwards. We'll start with jazz. So 32 said that they liked jazz. But already represented here is 2, 11, and 10. So that's 23. So we have 32 total minus 23. Let's see, 32 said they liked jazz. 21, 22, 23. So 32 minus 23, right? And so we have 9 students that like jazz alone. And now we have 48 that said they liked classical. So we subtract 48 minus 15 plus 11 and 10. And that is, let's see, 15, 11, and 10. So we're going to subtract 36 from 48. So we have 12 left that like classical alone. And we're almost done. Now we have to find out how many didn't like any of those 3 types of music. So since we have 110 altogether that was surveyed, we have to add up all the numbers in the region and subtract from that to get this number. So to get this, we have 12 plus 15 plus 11 plus 10 plus 9 plus 2 plus 8. Once we add it all up and subtract from 110, we get the number 43. So now we can answer all the questions. How many students do not like any of the 3 genres of music? And we have this number 43. How many like only rock? Well, that would be 8. How many like classical and jazz? That's classical and jazz, but not rock. Now, and means the intersection. So we're looking at these numbers 11 and 10, but not rock. So we cross off the 11. What's left is 10 students that like classical and jazz, but not rock. How many like classical or jazz, but not rock? A little slightly different now. The students that like classical or jazz are in both circles here, but not rock. So what's left is 12, 10, and 9. So we have 31 students that like classical or jazz, but not rock. And we are now finished with the handout. I hope you enjoyed the lesson. Stay tuned for next week's lesson. We will be covering the review for the first test. Have a good day.